So we had, in the last part, we had started our discussions on your non-degenerate perturbation theory. So we just did twofold degeneracy, right? So we came up with this formula for degenerate, non-degenerate twofold. Whenever you have twofold degeneracy, we came up with this formula, meaning when you have psi A0 and psi B0 states to have same energy E0, right? And if you are finding the first order correction after the perturbation is applied, say the first order correction, right? So the energies were lifted by, the perturbation led to the lifting of your energy E0, right? Okay. So the formula we came up with is this, where these HAA is, okay, let me say the general one, Hij is given by psi I, H prime psi G, right? So, and then we get these. So, when we calculate this, so the calculation is easy, these are just expectation values, right? We took one example, 2D infinite square well, and for that particular case, the 2D infinite square well, wherein the potential looked something like this. H prime was V0 and 0, this is otherwise, and this potential V0 was between x and a by 2 and between y and a by 2, right? So using that and calculating the matrix elements, we found HAA to be V0 by 4, HBB to be V0 by 4, HAB to be this, and HBA to be this. Okay. So now using this formula, right, using this formula here, we find my E plus minus to be V0 by 4 and then plus minus this, right? So I have got basically two different energies, right? The first order correction, the energy is splitted, right? Okay. So now in this lecture, what we are going to do is we are going to study, if not twofold, if we have some threefold, right, or fourfold, how are we going to handle the problem, right? So last time we saw that we had two equations, right? So after solving these two equations, we have got this, right? The formula for your first order correction. So now this can be written as HAA, HAB, HBA, HBB, alpha beta equals to E1 alpha beta. You must remember that our aim is to find the same formula for your n-fold degeneracy, right? Okay. So this can be written like this. So here what we see is your E1, right? E1, which is the first order correction to your energy eigenvalue, is nothing but the eigenvalue of the matrix this, right, which I am calling, say, so let me call this matrix as H prime, right? So my E1 is the eigenvalue of this particular matrix, meaning if I have some threefold degeneracy, right, threefold degeneracy meaning I have three states, psi A, psi B and psi C, all having same energies E0, right? How am I going to tackle that? So in such cases, your matrix element will look like this. So HBA, HBB, HBC, HCA, right? So that means in such cases also, let me again alpha beta C, alpha beta gamma, and your E1 again alpha beta gamma. Meaning, if you find the find the matrix elements, you find the matrix, right, by calculating each of the matrix elements, then what you do is you find the eigenvalue of this matrix. The eigenvalue of this matrix is going to give you the first order correction, right? Now to make it more easier to understand, let me do one more example here. and that is, I have my, now instead of 2D infinite square well, I have my 3-dimensional infinite square well, wherein the potential or your H prime, the new perturbed part, is given by zero infinity. This is between 0 is less than x is less than a. 0. So this is the potential for your 3-dimensional infinite square well. Okay. So the perturbation which I am introducing here is H prime, which looks like V0 0. X is 0 is less than x is less than a by 2, and if 0 is less than y is less than a by 2, and this is other twice, right? Okay. Now let us first look at the ground state, right? In this particular case, my psi nx, ny, nz is given by 2 by a to the power 3 by 2 sin n nx by x by a sin ny by y by a and sin nz by z by a, and my e nx ny nz is given by pi square h square by twice mx square plus ny square plus nz square. Now if I am looking at the ground state, let me call my ground state as psi 0. So it's given by psi 1 1, right? My ground state is given by nx1, ny1 and nz1. So which is 2 by 3 by 2 sin pi x by a, sin pi y by a and sin pi z by a, and the energy values to this will be given by pi square h square by twice ma square and 1 plus 1 plus square of 1. So it is 3 pi square h square by twice ma square, right? So this is for your ground state. But if I am doing for your first excited state, right, the same thing I am doing for first excited state, which is psi 1 1 2, right? Psi 2 1 1 2 1 and psi 2 1 1. So three different states will have correspondingly three different, these terms are going to differ accordingly, right? So first it is going to be pi x by a, pi y by a, but sin 2 pi z by a, right? So similarly you have three different terms, but the energy here, right? Let me call this as the ground state energy, is given by pi square h square by twice ma square, and nx is 1 square plus 1 square plus 2 square, or just change the, even after changing the position it's going to be the same, right? So which is 4, which is this. So that means my three different states are having same energy value, meaning I have threefold degeneracy. Because three different states have same energy values, I have threefold degeneracy. I cannot make use of my formula for twofold degeneracy. Hence, what I do is I write the matrix elements for this. Meaning, I construct my HAA So let my psi 1, 1, 2 be given by, say, psi A, right? And psi B be my psi 1, 2, 1, and psi C be my psi 2, 1, 1, right? So I have three different states, right? So I have my HAA, HAB, HAC, HBA, HBB, HBC, HCA. Now what I need to do is I need to construct this. So I will have three different states from here. I will construct a matrix element, right? So once I construct the matrix element, I need to find the eigenvalues to it, right? So those eigenvalues are going to be my first order correction. So here in this case, in this particular problem, so let me call this as my H prime, right? So my H prime comes out to be V0 by 4. I need to calculate all the matrix elements. Calculating the matrix elements is easy. What I need to do is, if I am calculating say H, B, A, I just need to find this psi B, H prime, psi A, right? Psi B and psi A, I am going to get it from here. My H prime is already mentioned, which is V0, right? And I should be using proper integration limits. This, I must remember, is a three-dimensional case. So I have integration running from dx, I have integrations over dx, dy, dz, and here for x and y, it should run from 0 to a by 2, 0 to a by 2, but for z, there is no such perturbation term, right? Hence it should run from 0 to a. So after doing all of that, what I get is, the matrix elements comes out to be this. Now, this is my matrix element, right? So now what I need to do is, I need to find the eigenvalue of this matrix. So, finding eigenvalue is simple. I just need to do H prime lambda I equals to 0. So if I do that over here, right? So my eigenvalues comes out to be, if my lambda is the eigenvalue here, then it comes out to be, only for this matrix, not don't take this V0 by 4 into consideration. For this matrix, it comes out to be 1 plus, let me call this term as x. So my x is 64 by 9 pi squared. So it comes out to be 1 plus x and 1 minus x, right? So what does this mean? This means that my E1, right? In that matrix I have V0 by 4 common. So it is given by, my new energies are, I have three different, there's been lifted by three different amounts, right? So it is E0 plus E0. So I have three different amounts. So I have V0 by 4 left outside. So it is V0 by 4, V0 by 4 into 1 plus x, right? And V0 by 4 into 1 minus x, right? So this is my first order correction to the first excited state for this particular problem, right? So whenever you see some matrix element already given and then you are asked to find the first order correction or the second order correction, all you need to do is find your eigenvalues for that particular matrix. So that gives you the correction. Okay. Even for your two-fold degeneracy case, after obtaining all the matrix elements means whenever I am writing the matrix, whatever goes in here, these terms are called the matrix elements. So if you find, once the matrix element is found, construct the matrix, find the eigenvalues, and then you are done, right? So that's it. Thank you.